Hello everybody. Hold on, let me put my headphones in here. Whoops-a-daisies. Give me just a second here. Okay. Hello everybody. Gonna try to do this virtually here. Okay, I'm trying to provide some sort of videos, so those of you that would like to get ahead or would like to have some guidance through the homework, you'll have this video to utilize as well. Okay, so hopefully this will turn out better than I probably anticipate. So let's take a look at this. So we went through a lot of these problems in class, okay? And so the idea in the beginning is that we want to be able to take this equation, put it into our calculator, and then be able to get a nice image from our calculator. So the first thing you want to do is make sure you put this thing into your calculator correctly. All right, so take your time, negative 4.9x squared plus 28.3 plus 100. Okay, now in order to set our window, okay, to make sure that we got everything that can fit. Well, first, let's talk about our negative x and y values, okay? So as we read the problem, okay, we're talking about this physics club that's shooting off a rocket, okay? It launches at 40 meters per second at 45 degrees, okay, from a height of 100 meters, okay? We're not really concerned about all that. We're concerned more importantly on this right here, okay, and then obviously the equation I got circled, okay? This other stuff is kind of physics stuff, and we won't be dealing with that. So anyway, all right, and so what we're looking for is to get this image in our calculator, okay? And the reason why we're only concerned about this part of our graph is because x represents the number of seconds time, and y represents the height in meters, okay? And so why we're not too concerned about negative numbers or negative x and y values is because over on this side, right, we're dealing with, when we're on the left side of the y-axis here, okay, we start dealing with negative time, right, which wouldn't really make sense to this problem, okay? We're not really concerned about what's going on, you know, seconds before the launch, okay? We're worried about when this thing is launched, and then more importantly, when it hits the ground, okay? And so that's what we're trying to capture as far as an image in our calculator. We're just trying to capture that trajectory, okay, of our rocket ship. All right, and we're not concerned about negative y values either, because we're not worried about the rocket going into the ground and barreling to the center of the earth. Okay, we're only worried about when it starts, right, when it's initially shot off, and then again where it hits the ground. Okay, so this is the image that we're going to want to have in our calculator. All right, so in order to do that, we need to adjust our window. Okay, and so if you look in your table of values, all right, now again, we are not too concerned with, whoops, stop doing that. There we go. Hold on, I didn't plug something right in here. Oh, forgot the x after the 28.3. There we go. That's what's messed up. Okay, so go to your table of values, right, and you'll see, okay, in your table of values, see at 0 we got 100, okay, and then, you know, at 1, 2 it starts to go up. At 3 we reach 140.8, and then after that it starts to go back down, 134.8, all the way till, if you notice, between 8 and 9, okay, at 8, we got 12.8, and at 9, we're at negative 42.2, okay? So this is where we want to keep our domain and range, okay? And so our x min, all right, I like to give myself a little bit of room to the left, okay? So I'm going to make this a negative 5, okay? We don't need to go back all the way to negative 10. But my x max, okay, if it looks like we're hitting 0 somewhere between 8 and 9, okay? And so I'm going to make my x max stay at 10. Now we're not changing our scale. Our scale just decides our increments as we go up and down the graph. We're just going 1, 2, 3, 4, 5 as far as x and y values. Okay, y min, again, I'm going to keep this at negative, well, let's go negative 10. Okay, in order to find our roots, okay, we need to give ourselves some space there. So I'm still going to keep that at negative 10. My y max, okay, if you look over here, the highest value we see is 140.8. So I'm going to make my y max about 150. Okay, so let me adjust all this in mind. Okay, and once you've seen it like that, you hit graph, and you should see a nice picture that looks like this. Okay, all right, and so that's what we want to do first, right? That is our goal to start off with, okay? Now, the next part, okay, we need to find our y-intercept of this function. Well, our y-intercept is just when x is equal to 0, right? So when x is equal to 0, y is equal to, you go to your table, and it looks like y is equal to 100. Okay, so our y-intercept is 0, 100. And what does that represent in the function? It means we are at 100 meters high before launching the rocket. Okay? It's like, or, to be fancy with it, just call it our starting point, right? It's where we're starting, 100 meters up, right? That's where we're at. So we're starting at 100 meters. Actually, we're on a cliff, okay? So we're shooting the rocket off a cliff, okay? So the next part, find the x-intercepts of this function. More importantly, we're looking for when y is equal to 0, okay? When we're crossing this line, all right? Now, because it's a quadratic, all right, looks like there's going to be 2 intersections, okay? Nothing wrong with that, okay? But one of them isn't going to necessarily make sense to our problem, and it's going to be the one that's negative, right? Because again, we're not talking about negative time, okay? We're not shooting the rocket backwards in time, all right? We're not starting down here. We're starting at, excuse me, 100 feet, okay? And so when we find these x-intercepts, right, what we're going to find there is that one of them makes sense and one of them does not, okay? So in order to find these, right, there's a couple ways we could go about it, okay? We could take this guy, all right, and we could use the quadratic formula. Okay? We certainly could do that. Right? But the whole purpose of this lesson is to utilize your calculator so that we don't have to do that. And so what we're going to have to use is we're going to have to use our second. Okay? We're going to hit the trace button, but we're trying to get that calc above. So second trace. Right? And then we're going to click 0 at 2. Okay, so once you click that, you're going to get your picture, right? And so your cursor, as we go from left to right, okay, we want our left bound to be above where we intercept the x-axis. So it'll be your left bound. Right, your right bound will be just below it. Okay, there'll be your right bound. So you hit enter, and then your guess is somewhere in between those. Okay, so you're telling your calculator to look in between those 2 lines. You should see these 2 little arrows at the top. Then you know that we're going to look for it right in this little spot right here. And then when you hit enter again on guess, we should get 8.2, 0. Okay, and so what does this x-intercept represent? It represents when our rocket hits the ground. Okay, that's what it represents. Okay, the other x-intercept, we could find that as well, so I'd have to do the second thing, the same thing, second calc. We're going to go to the 0, and then we're just going to go to the left side. So on this side over here, all right, your left bound is actually going to go below where we intercept. Okay, so we go below, we go above, somewhere in between. All right, and we get negative 2.47, comma 0. Okay, so are both of the intercepts relevant to the situation? No, they are not. Okay, because we don't want a negative value representing time here. Okay, all right, so the only one that makes sense is 8.2, and so 8.2 seconds till it hits the ground. Okay, that's what the question's asking there. Okay, find the x-intercepts. We did. What does the x-intercepts represent? Where our graph hits the ground. Okay, what is the highest height of this projectile? Okay, so this involves using the same second calc button, but instead of picking 0, we're going to pick the maximum. Okay, we want the maximum value, the highest our y value goes. Okay, and so again, our left bound, all right, we'll go to the left of our vertex. Our right bound will go to the right of our vertex. And then we're just going to guess somewhere in the middle. And so our vertex, okay, or our maximum value, all right, is when x is equal to 2.88, okay, our y value is 140.862. Okay, so what is the highest height for this projectile? 140.862, and this is meters, and that is our answer. Okay, so you might have to utilize those videos in order to find your maximum value or your x-intercept. Okay, again, we'll work on these in class, but I just want to reiterate how to find those things. Okay, so let's take a look at number 2. All right, so number 2, we're going to start the same thing. We're talking about a golfer, though, and our golfer is talking about his chip shot right here. Okay, which can be, which his trajectory can be written as this equation right here. Okay, so I want you to plug this into your calculator. Okay, so now there's our function. Okay, now if you hit if you just hit graph, okay, we still get a pretty nice picture for this. All right, I'm going to kind of keep my window the same. I mean, I guess I could make it look a little nicer. Maybe I'll shorten my x max up. Okay, so if you hit the second table, you'll see that between 0 and 5, okay, our trajectory is in the air. So our y-intercept here is just 0, 0, right? Which makes sense because if you're golf, right, you always kind of start on the ground and then it comes up and then whatever goes up comes back down, okay? So that is what our trajectory would look like. Again, starting at 0, 0. All right, I'm going to change my window up so that instead of going up to 10, all right, I'm going to only go up to 7. So I'm going to go negative 5. My x max, I'm going to go up to, let's say 7. It's keeping the scale at 1. Okay, my y min, I'm going to keep it negative 10. All right, and then my y max, okay, if you look in your table of values, all right, you'll see that the largest we see is between 3 and 4. I'm sorry, 2 and 3. And we're at 96, 96, and then it looks like at 4, we start to go back down. Okay, so what is the greatest height of the ball? Well, we can't say about 96. Okay, so again, we're going to have to use that maximum value in our calculator. So we're going to go to second, trace. All right, more importantly, we're hitting that calc button. So second calc, and you go down to maximum. Okay, so for this one, you're going to put your left bound right here on the left side. Put your right bound over here on the right side. And then we'll put our guess somewhere in the middle. And I'm getting a maximum, or a vertex, I'm sorry, my vertex is 2.5, comma, 100. So what is the greatest height the ball reaches? We don't want to put that point there, but we want to say 100 feet in the air. Okay, so make sure when you're answering these, you don't just put 100, you put 100 feet because it's a real world problem, right? These numbers actually mean something. Okay, how high is the ball after 4 seconds? Well, we could find that, right? We don't have to look too far. We can just look right on our page here. At 4 seconds, when x is equal to 4, our height is 64 feet. At what time does the ball hit the ground? Okay, well, what that is saying is at what time is our height 0, right? When does our height 0? You know, when does our ball hit the ground? And so if you look back in your table at 5, you'll see that we have a 0 there. So therefore, what time does the ball hit the ground? 5 seconds. And lastly, okay, at what time is the ball at a height of 22 feet? Okay, so this right here, all right, it's just a fancy way of saying when y, or when our height is 22, what is our x value? Okay, so being it's a quadratic, there's 2 answers for that. Okay, so what we're going to have to do is we're going to have to set this equation equal to 22, right? Because at some point there's some x value where our height is 22 feet. More importantly, 2x values, right? So in order to solve this, okay, I'm going to have to bring this 22 over. So we're going to have 0. I'm going to just put this in standard form. Okay, I'm going to take out a 2. Okay, always look for a GCF where you can. So it's going to be a negative 8x plus 40 minus 11. And now I'm going to have to use the quadratic formula. Okay, and so our a value is negative 8, our b value is 40, our c value is negative 11. So I plug everything in. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Fill in the blanks here. So we scroll in. So it's going to be negative 40 plus or minus square root of 40 squared minus 4 times negative 8 times negative 11 all over 2 times negative 8. Okay? And so first thing you want to do is solve underneath the radical, figure out what all that mess is equal to. So I go 40 squared minus 4 times negative 8 times negative 11. And I get negative 40 plus or minus square root of 1248 all over negative 16. Okay, so I'm not going to simplify it any further than that because I know that I can just plug this in my calculator and figure out what my 2 x values are. Okay, so when x is equal to a negative 40 plus square root of 1248 divided by negative 16, I get negative 40 plus square root 1248 divided by negative 16. I get x is equal to 0.29. Okay, and then our other one, x is equal to negative 40 minus square root of 1248 divided by negative 16. And here, divided by negative 16, I get a positive 4.71. Okay? And so what our answer is this. All right, remember, because it's a quadratic, so at what times, plural, is the ball at a height of 22 feet? We could say 0.29 and 4.71 seconds. And that is our answer. Okay, so for homework, all right, we're going to try to get through these last 4 problems. So depending on what class you have, there's different instructions on what I want you to do for homework. But basically, if you'd like to get a heads up on these, if you'd like to get a ready up for Monday, go ahead and try to finish all these problems. Okay, and then the questions that you don't know how to get, we will certainly answer in class when you guys return on Monday. Okay, so good luck, you guys, and